All right, we're going to do this both with and without a calculator. So triangular trig is going to be, without a calculator, then you'll be using unit circle, and you'll be using nice triangles that work out well. With a calculator, that'll be when you don't have nice positions on the unit circle, or you don't have nice values on the triangle that don't work out well. All right, so let's start on the non-calculators. And your homework is divided up into two sections. There's a section of problems that I labeled don't use your calculator on. Regardless of what the book says, I don't want you to use your calculator. And then there's a section of the homework that says, okay, go for it, use your calculator on that one. So this will be the non-calc. All right, so example A. Something like this without a calculator. So evaluate the cosine of the inverse sine of the fraction 4/9. And you don't get your calculator to do that, so you can't just type it in radian mode and come up with the value. This is going to be done on a triangle. Okay, how do you know if it's going to be a triangle or a unit circle? Well, the number 4/9 isn't on the unit circle. It's not one of the ones that you memorized, being like pi sixths or square root 2/2, or one of those recognizable ones. So then you're going to know, all right, I'm going to tackle this with a right triangle. And so it helps me to just sort of have a visual of what I'm doing. If I'm working with the sine inverse of 4/9, I know that sine is based on the relationship of opposite over hypotenuse. And so if theta is the lower, the angle of ascension, or the angle of elevation, I think is the geometric term for that. If that's the angle of elevation, then the opposite side needs to have the value of 4, and the hypotenuse side needs to have the value of 9 in order for this triangle to satisfy that the inverse value of sine would be 4/9. And so we start with this. According to this picture, sine of theta is 4/9. And so theta is the inverse sine of 4/9. Okay, that's basic trig. And so I can do a substitution. If theta is equal to the inverse sine of 4/9, then I can replace the inverse sine of 4/9 with the expression theta. And so this becomes cosine of theta. And cosine of theta, I need to know the adjacent side. So that's where the Pythagorean theorem comes in handy for us to figure out what the value of that adjacent side is, that b value. So a squared plus b squared equals c squared, 4 squared, plus b squared equals 9 squared, so that's 16, plus b squared equals 81. So b squared is 65. So the value of b is going to be the square root of 65. And so, am I doing that right? 85 minus 16, yeah? I feel like something didn't come out right. Okay, so then the cosine is going to be the square root of 65 over the hypotenuse of 9. So you're just using a right triangle to solve that. Any questions on that one? In a similar way, you can do that with tangent too. So you could say evaluate the tangent of the inverse cosine of 3/7. And so again, you're like, 3/7 not on the unit circle. And so you'd set up a right triangle. You could put theta wherever you want, but I typically put it in the angle of elevation. And if the cosine inverse is 3/7, then 3 and 7 are going to go on the adjacent and the hypotenuse sides, which leaves me to figure out, using the Pythagorean theorem, what the value of a squared is. So a squared plus 9 is 49. So a squared would be the value of 40. And so a is the square root of 40. That's going to be 2 rad 10. So 2 rad 10 would be the value of my missing side. And so then this would be, instead of tangent of the inverse, it'll be tangent of theta. And tangent of theta is 2 rad 10 over 3. Now you can also do this on the unit circle. Okay, on the unit circle, you could say, all right, you know, what is the sine of the inverse cosine of rad 3 over 2? Okay, the sine of the inverse cosine of rad 3 over 2. And so now that's going to be a unit circle value. And so you'll need to know the radian measure where the cosine value achieves rad 3 over 2, which is pi whats. Where's rad 3 over 2 on the cosine value on a unit circle? Okay, that's going to be, remember cosine is the x value. Yeah, cosine is the x value, so it's going to be pi 6. And so we've got the sine then of pi 6. And the sine of pi 6 is 1/2. Okay, so it's just a review of how it goes around the unit circle. So just remember those values, that x comes first, y comes second, which means cosine is first, cosine theta followed by sine theta is the order when you're working on a unit circle. And so you're looking for values there. Okay, now when would you use a calculator? So here's the example of ones that would be calculator type trig questions. We've actually done something like this already. In your quick review on the day that we were warming up for this, it was a quick review one. So something like solve the tangent of theta to be -2, and in a specified value of maybe from -pi/2 to +pi/2. So that's going to be a calculator active question. Well, you'll solve that the best way with graphing, I think, because you'll realize that when you make your graph, and then you have a horizontal line at -2, that you'll be able to then find the intersection as the value. And because it's limited to -pi/2 to pi/2, we only are worried about one cycle. If we extend the domain, if we extend it to say -pi to pi, then we'll have multiple of these the cycles of tangent in there. So if we were to extend that, we'd have an extra one here, and then an extra one here, and so you'd come up with more solutions within that interval. The one I feel like maybe you're going to get tripped up on is how to use your calculator to solve it when it's not sine, cosine, or tangent. But like, what if you need to solve the cosecant, excuse me, not cosecant inverse, cosecant is equal to 4. Like, how do you type that into your calculator? Because there is no cosecant button. And cosecant's not the same as sine inverse, so don't type in sine inverse. What is cosecant the same as? 1 over sine. So in your calculator, you would need to type 1 over sine is equal to 4. And so this would go into your y1, and that would go into y2. And then you would use your calculator to solve that. And so the graph of cosecant is going to have these branches with asymptotes. And then 4 would be a horizontal line up here. And depending on the window, you could have 1, 2, or multiple answers that were intersecting. And so you would need to come up with as many as were in the window. So we've done that already. We did that on that day we had our quick review. Okay, so that'll cover that.